Hello and welcome. I'm Bill Wake. We're here on episode 9 of the Elm interpreter written in Swift, and we're at the point of doing monad parser combinators. I don't know. We've come a ways here. A parser is like what I think everybody learns in school if you take a compiler class. You know, it takes a string and it produces at least a Boolean result telling you whether it succeeded parsing or not, and often a tree or some other sort of data structure that represents the contents of the parse. We started working with parser combinators, which take they're sort of functional type things that you give them parsers and they produce other parsers. So an or, like you might write a vertical bar in a grammar, you can define a combinator that says, give me two parsers and I'll try the first one. And if that succeeds, I'll give you the result. If that fails, I'll try the second one and give you the result of that. If that fails, it just fails. Or we've been working on sequence. And the challenge we have is with or, you're returning one result and it's fine. But with sequence, you've got a series of things like we have the many combinator that returns zero or more, or the many one returns one or more. You get this list of things back, okay, and it's a list, and that doesn't sound so bad. And I guess the original way of doing this back 30 years ago or whatever, that's kind of what they did. But what they found out was you get this list, but you have a sequence, and one of its elements is a sequence of other stuff, which is an element has sequences and manys and whatevers. And all of a sudden everything starts getting stacked up, so you have arrays of arrays of arrays of characters and things like that. And as you try and merge these things together, if you've got a sequence, an overall sequence contains a single item and a sequence. Well, now the sequence is returning an array. The single item is returning one item. You can't mix those in a Swift array without wrapping them in some type. And so we've done, I guess I'd call it a bit of a hack that says convert the single parser into an array yielding parser. I don't know, maybe it's not a terrible hack, but what you end up with is I've got all these things of different levels of nesting, and I have to figure out how deeply to nest them, and maybe some of the lists could only be one item, and so I can unwrap them, and it's just a mess. And certainly my intuition is like, oh, it should be easier. And this is where the monad stuff comes in. So we take the parser combinators and they say, if you pick your types correctly, you can make it so that everything comes in flat, basically. And you've got control over what goes on. Really, the real issue is control. So I'm not a deep static functional person by background. So I'm stumbling through. So you get to watch me stumble. And as always, if you have suggestions or ideas, they're very welcome. All right, so let's see what we've done. Let me back up a little bit. We defined two new functions, and somewhere I've got a link to the paper they're from. So there's this bind function. We're calling it monad bind, just because of naming clashes. Okay. It takes a parser and a function, and it it applies the function. Well, let's see. It's complicated. Let's get down to the real example here. Um, Here's this one. Bind succeeds when both parsers succeed. So it's going to take your parser and it's going to combine it with a function in such a way that it parses the first thing off from the original parser. It runs the result of that through your function, and then it lets your function yields a parser, and the parser parses the rest of the input. So it's a little bit of a dance. Let's see the code for it. Monad bind. I think I left it down towards the bottom. Yes. Okay. So here's monad bind. It takes a parser returning A's, which in our case probably is character, but at some point is going to be Elm types or Elm. Basically, it's abstract syntax tree nodes that we use for Elm interpreting. Okay, we don't care what the type is. We just want to know if you've got the parser and a function that goes from that element to some other element, then we're going to return a new parser. So this is a combinator. It takes parsers and produces parsers. And the way it works is it's going to give us a new parser returning B's by line 208, take parser.parse of input. So we parse with the original parser. That gives us a value and a result, value and a rest. So it gives us the value we parsed off the front and then the rest of the input that we can work with. And then we take that value, apply the function, and parse the rest with the new function, with the new parser that we created. And we return that whole thing. Okay. So, how you get here, I don't know. I mean, it takes a certain insight, and I didn't like, oh, let's refactor this, and oh, this popped out. I went to a paper that said, here's a way to write a monad bind, a bind for a monad. Okay. The second one that we have that we did yesterday, it's a result, and basically I don't like the name. I just don't have a better one. Its job is it's going to create a parser that when you give it a value A, it puts A at the front of the parse. So the value, whatever input you have, basically the value is there as the result of this thing. So it's a parser that produces a value and gives you a rest of the input. The value it produces is a hard-coded value you gave it, and the input is the whole original input. So I think of it as you've got an input stream. I don't know which way my hands look like. My lighting's a little wonky today for some reason, but you've got an input stream. Let me put it over here. Okay. Here's the head of the input stream. That's normally where your parser consumes. Okay. But what we're doing is we're sticking an extra element in front of the parser, and when somebody asks for it, they can get it back out. Okay. So it's sort of the result of the parser is pull out that value first. So it's sort of a way to sneak in a new value. We'll see it used shortly. All right. And then the thing we're trying to work on, and we're just starting. So, hey, you haven't missed much there. If you can get this one in your head in 2 minutes, the sequence parser is going to take two parsers and say you must match parser 1, and then the rest of your input must match parser 2. All right. And the rest of your input maybe makes the bell go off and go like, oh, I did rest in my input in line 209. And our implementation will use this monad bind somehow. It's got a suggestion. I'm still not clear if it's right or not. The other thing we're struggling with, let's see, back to the tests. So where we left off, we're going to test. We got sequence fails if you just give it bad input, and that's not hard to do because we hard coded a parser that would always fail. Maybe that would be a useful thing too, but let's move on. Okay, so we want to do check parser succeed. So give it a parser, which is the sequence parser we just built, and input A, B, X. It should find the A, find the B, and have the rest of this be the X. Now the challenge here, and I think I need to change the results. I mean, really, I think what I want to expect is not a pair. It's just the array of the two elements. So this is what I'm talking about. This thing is not right now. It's not flattening anything. It's wrapping arrays of characters into pairs. It's anonymous pair basically in Swift. And I think we want to make it just, I think we would like this to be the value. The array AB. And I'm not 100% sure on this monad bind. I think it may be that I think we want to flatten the result somehow. And I'm kind of combining two people's papers, so I may be messing myself up. But if function A returning B. Okay, and let's see what this B does. Our parser, oh, he's just doing match. Okay. Now well, let's build this, but it's still going to reject it because I don't think our function is going to return the right thing. And this is another place I'm not so sure about what we're doing. So one of the papers I looked at, they were all about making everything arrays consistently. Cannot convert a value of type string to expected argument type character. So am I getting back? I don't think I should get back the AB as the string. Well, we got to look at match to figure it out. All right, so match of a string says return a parser of characters. Match returns an array of characters. Oh boy. I don't want to bust everything up. I realize I'm making a big transition here. Cannot convert value of string. I wonder which thing it's complaining about. Cannot convert character to... What is character? That's parser. No? Let's go to this method. Parser test helper. So check parser succeeds. It's a parser of A's. Parser returning A. And I think it's complaining that this... How would it know what A is if it doesn't believe what it's given? Oh, expected... Okay, yeah. So if it's given... Yeah, I think our parser... monad bind return function of parser rest. So the function... Oh, we haven't done anything yet. Okay. It's a parser of AA. I think this thing should be parser of array of A's. I think. Okay. Somehow we got to get this all lined up in the same type, and I think array of characters is going to be the right thing. So build again. All right. I think we're getting progress. Cannot convert value of type string to expected element type array of character dot array literal. I don't know what that means. AKA array of character. Yes, that's what we wanted. Cannot turn array of character. Boy. Okay. Let's go back to match. I may make a new match. All right, so match takes in a prefix of string. Prefix isn't a great word there, but it takes in a string. It produces a parser of characters. It produces a parser producing array of characters. Okay, so when we call our monad, see, I would like the type of seek to be the same as the type of this. It would be nice if match returned an array of these things. So let me pull out match. Ooh, let's just get the right one. And I don't know if I'm overloading things in a good way or not, but all right. So we're just going to put a version of match out here. Match 2. Match temp. Okay. Because I'm mostly just trying to get these things together. Okay. So he returns array of character. Right, but if he's array of character, I don't know, maybe this thing is A again? Is that's back where we started, I think. Well, let's put match 2 in our test. Match temp. I just want to be able to modify it and not be too tied to the old. So I'm still kind of, I don't know, I wouldn't call it a spike really exactly. It kind of is. I'm writing all the tests and all that, and if it works, I want to keep it. So, tell me what it is. Speculative generality, who knows? I know we got something terribly wrong. Okay, this is good. I hope the test fails because it hard codes returning nil, but I think at least we got the types matched up. Now, I hope this is what we are hoping for. It's hard to tell. Okay, I'm seeing an issue. All right, I'm seeing the video appears to be disappeared on you. I am streaming, I am recording, so I'm not sure what's up. We'll give it a few seconds. Let me refresh my monitor page. Okay, sorry. All right, seems to be nothing. Okay, so I think we finally have our failing test. I don't like the fail, but it's running and running and running. Where's that CPU monitor thing? No. I know there is one. Is it the X? No. I don't know what popped that up before. Maybe run? No. What's odd is I have no output. And maybe it's just slow. I don't see the simulator. Okay, simulator's still waking up. Let's move that over here. Well, while that's waking up. Okay, there we go. Yeah. All right. Should parse, but did not. Okay, and that's what we expect at this point of things. All right. So now we're going to go to parser. And I didn't really change anything, did I? Except the name. That's okay. If I can use the real ones, that'll make me happy. Okay. So now parser in nil is not the real return value. We have to do the real thing. And here's the paper I mentioned. So they say if you've got the monad bind, you take the parser and the function you give it is this big anonymous lambda x whatever. They format it in a way, I assume it's being formatted, I don't know. It looked to me like, p bind lambda x goes to, q bind lambda y is all linear and stuff, but I don't think it is. I think it's a big nested function. And so what you see is the p bind lambda, it's going to call this function with the lambda with whatever it gets out of the p, the first parser. And that's going to say, hey, you need to bind it to the rest and then create the result xy. Well, if you remember, result xy was going to take whatever you gave it and stick it at the front of the input stream. So it's this sort of current value and then the rest of the input stream. Okay. Now, okay. So, I mean, theoretically, I don't know if I can copy this out of the paper even. No, but theoretically, we can return that. So let me see if I can do it in here. Okay, so this returns a new parser, and then the input in. Okay, and we're going to take parser 1. Well, we're going to take monad bind of parser 1 with some function. And that function's going to be, well, it takes an input, which we can call $0. That's fine. Well, let's name it. Let's call it result 1. I think I can keep that straight. Okay, so parser 1 gives us result 1. And then in there, we want to do another bind. So monad P parser 2 is Q. So it's a monad bind. Parser 2, well, what's inside? It's a parse function. Okay. Now parser 2 is lambda, it takes lambda y, which is result 2. All right, and then its result, hopefully this all pans out at the end. Its result is going to be result 1, result 2. Please just work yourself out. Parser of array of A's to parser A input question. Okay. I think this thing is a parser. Let's just say return. We don't need the input because we're dealing with just the functions. How's that go? Oh dear. Now this is where I'm not sure about our monad bind, because all right, cannot convert parser of array yielding array of A's to parser of A. But parser 1 parser of A's now I'm wondering if I can do this. If I bracket everybody, I don't know, I feel like I shouldn't have to, but this is my exploratory part. Like if we can get the types right, I think lots of things will work better. Okay, cannot convert parser of AA to result type parser of bracket A. Now the other thing that happened, let's see, this paper, it's Graham Hutton and Eric Meyer. It's basically introducing this monadic, I guess I should have said that for my title, monadic parser combinators. But they start from scratch. It's a good paper. I don't know. I've read it a couple times, and I'm definitely up to at least page 4 of it. I'm making sense of it. I feel like I kind of get everything up to about where we are. Surprise. This stuff makes sense to me, but a step further, there's just a gap there in my head. But let me go back to their bind, because I used a slightly different one. Where's bind? Seek. Okay, here's bind. Yeah, so this is the old way. Wadler 85, Hutton 92, Fokker 95. And that's kind of what we have, that we keep getting these things stacked up and nested deeper and deeper. Okay, so they're bind, and I don't know Gopher, which is a functional language, well enough, but what their text says is parse P, we did that. Get a list of value string pairs. F's a function that takes a value and returns a parser. Apply it to each value in turn. This results in a list of lists that can be flattened into a single list. So I don't do any flattening in mine, and I wonder if that's a flaw. Okay, so I just don't know. And they're still talking about parser A's and parser B's, so they're not requiring brackets on these things, but when they use it, they seem to do that. The mouth sounds probably don't help any, huh? So the difference in this is, like, their notation seems to say I think what their notation is supposed to mean is that for every V input coming back from P input, so that implicitly it is an array of stuff. I don't know, but I think that's what it's saying is the V input is an array of something, and we're going to apply F to each value and parse input prime and then build a list of those and flatten them. Why concat would be flatten, I don't know, but that's the text of what they're saying. Flatten it into a single list using concat. Okay, so I'm going to read it again. F's a function taking a value, returning a parser. It can be applied to each value. Well, let's see, this one. Parser P is applied to input string, yields a list of value string pairs. Okay. And then we apply the function to each one in the list with its unconsumed string. And we get a list of value string pairs and flatten them. This avoids the problem of nested tuples because the results are made directly available for the second. And then here's how you use it. Bind, and result, which is our sequence one. Okay, now let's see. I think this is the other paper I was working from. He's changed the terminology a little. He calls this pure. I think he's more of a Haskell kind of guy and familiar with this from there. But pure is like our result, which means I could probably simplify it. It just it takes the value and sticks it on the front of the input you have. Okay. And I think that's, we pretty much do that. Yeah, I could change this to $0 and it would be the equivalent. Okay, so his pure is our result. All right, now here's the monad bind. I guess in Haskell it must be greater equals, but it takes a parser of type A and a function from elements of A to parser of B, and produces a parser returning B's. He returns parser input in. Yeah, this is similar to what we did. If result input equals p.parse input, return f.result of parse of input 2. I don't see any flattening in there, right? Because it just returns one element to one element. Okay. And that's kind of what we're doing. Where's our monad bind? I guess I flipped the logic a little bit. If it's a value rest, parse the input, else return nil, and then apply the function and get the result of applying the parse to the rest. Yeah, which I think it's equivalent code. Now, and then his sequence parser, he doesn't define it straight away. So I don't know where, if he's getting off. He's got these intermediate operators, and maybe they're doing the flattening or something. He does define this fmap which is $1 in Haskell, I guess. You give it two types. You got a function A and B and a parser A, and it produces a parser B. The way it does it is it takes your parser, binds it to A in pure f of A. So pure is the result. So he's going to make a result out of the f of A and bind that in and call that as his function. Okay, so the input on his function. Okay, so you're saying take a function, apply it through to this parser, and get a new parser. And then let's go down a little more. He defined, okay, this is that thing. So here's his function. He says a parser A to B. Oh, interesting. So he's got a little different approach here. A parser producing a function from A to B. I don't know. That feels very different. A sequence action. Constant is a function applied from P to Q. Discards the value of the second argument. Now, this sort of thing is useful if you're dealing with spaces. So one thing combinators do is work with spaces, and you don't have to tokenize first. So that's kind of one of their selling points, I guess. But notice this: if it really just discards, it's a sequence, but it discards the second item. So if we had a situation where spaces are required, but we don't want to look at them, they're just required to separate things, which seems like some places Elm does that. You can define a token operator. I think they called it in the other paper I read, or one of the other papers. Token takes a parser, basically can take, it takes a parser, and then it implicitly takes your spaces parser and removes the second element, of the result. So it only results in the result of the first parser, which is the token you care about, and throws away those spaces. So makes sense. But I don't know. I don't see anything getting rid of doing the flattening in this implementation we have. Now, whether it should, I don't know. This is it's like I somehow should. Okay, let's see if we can make that happen. Okay, so right now, value of parser of A to closure result type parser of A. I think it's the same issue that we just had before, just one's wrapped up more. Okay, so cannot convert value of parser of A. I don't know if can I do a flatten here? Let's Swift array. I think it's flat map, but I don't remember how to use it. Well, I'll try a more direct search. Whoops, Swift flat map example. Flat map can flatten an array. Flat map. Numbers.flatmap $0 takes this list and it prints just the list of the array, in the whole array. Numbers.flatmap, and I can just $0 like that. Yeah, so that's the kind of thing I'm after. You give it a function that does the mapping. All right. Okay, it does. No, cannot convert value of type empty. Now I don't see why that's empty because it's a parser of B. Ugh. Wow. So who is to closure result type parser of A? Okay, so monad bind takes a parser of returning A's. In this case, returning array of characters because we give it a match temp. And a parser, basically, it's a function that takes strings in and produces arrays of characters. Do I have to flatten each one? That seems... Type empty, because I don't see why monad bind would produce an empty. Like who in here produces empty? So maybe I gotta let's pull things out a little bit. Okay, so let's take this. Equals that. Flat map is deprecated. Oh. Compact map instead. Okay, if it works the same, I'm all for it. Okay, so in the end, we're saying monad bind takes a parser and a function. Cannot convert the return type of parser of A to return type parser of A. Okay. Now the type of function, let's see what they think that is. Function takes A's and produces parser of array of A's. Okay, so something's already screwy. Okay. So, like, we're trying to get the complexity of only and unwrapping and wrapping and keeping track of who's got how many. I think if I put an only here, I might improve the world. Let's see. No. Result 1. Okay, so match temp is a parser producing array of characters. So A is array of characters. It produces array of characters. Parse 2 should produce the same thing, array of characters. It does. Now, parse 2 gets result 1. What type are you? Oh, come on. Well, he's got to be a function. Okay, so this was a parser of... Let's see if I can get it all in one. Okay, so this is a parser returning A's, which is an array of characters. We need a function that takes an array of characters and produces a parser of that type. Okay, so result 1 should be array of characters. And I think... Do I need to... Result 1 produces array of characters. Let's suppose... Let me break out function 2. Well, let me try another one. Let function x is result 1 in result 1. And let's see if we put function x in there. No. Okay. Parser of A. Okay, now my function has to take an array of characters, because that's what it's getting here. And it must produce a parser. Well, monad bind produces a parser, so that seems okay. This thing takes parser 2, which is producing array of characters. It passes a function, parser of array of characters passes a function that takes an array of characters and produces something. Okay, so this should be an array of characters. So I got two arrays of characters, and I'm producing a result that wraps up an array of characters. Can I figure out the type of this argument? It's, well, result one's array of characters. So this should be array of characters compact mapped with this. Let's go find that documentation on compact map. Wow, you're still thinking, hey? Not a good sign. All right. Well, we'll let that think another minute. It's time for a break, so let's take 2 minutes, maybe 3. Grab a drink, whatever, and I'll see you back, and we'll see if we can get this array type nesting straightened out. Hi, welcome back. All right, let's find compact map. Okay, it takes an element of result. It takes an element to an element of result. Question mark returns an array element of result. Oh, it returns. Okay, yeah. So you can, your function that you pass in can omit stuff if it wants to, and you return nil, then it omits it and returns an array of result. Okay, so it is like flat map. I guess it's got the same type signature, it looks like. I don't know why they deprecated it then. Okay. All right, so in here, result is array of character. Result 2 is array of character. The whole thing is returning. I don't know what type result 2 is, and this gives no clue. Oh, it does now. Oh, A goes to parser of result of A. Now maybe my A's do need to be bracketed here. I think I'm saying you give me a parser that returns an array of stuff. Whoops. A parser that returns an array of stuff. Another one that returns an array of stuff. And I give you a flat map back of an array of stuff. Ambiguous. Okay, why are you ambiguous? Because he's not following compact map? I wish I got more clue about that. type is ambiguous without more context. I'm the one that needs more context. Okay, so this is array of character. Array of character. You take an array of characters and you get an array of characters is what we should be getting back out. Is there a... So it takes a function returning... I don't quite get it. It knows... Okay. All right, so now parser is returning parser of array of characters. So A is character. Function 1 is result 1, which is array of characters because that's what parser 1 produces. And parser 2, result 2 should be an array of character. This should be an array of character. Let's take this part off. Compact map. Okay, I think it should complain about the double array now. Oh, it's still complaining about more ambiguous. I wish it would explain what it meant by ambiguous here. I got a parser of A. Let's make sure my tests actually compile. They seem okay with it. A sequence takes a parser of array of characters, producing array of characters. Another parser producing an array of characters. We would like it to produce an array of characters. That would solve all kinds of problems. But monad bind is ambiguous. I don't know, can I say of array of character here? I shouldn't have to. No. Cannot find result in scope. Result 1 in scope. Okay. Without more context. Well, it's kind of like saying our monad bind is not returning what it expects. Well, okay, because B can be anything. So the function converts. Well, I think I'm going to put this back. I sure think that result 1, result 2 should be an array of characters. But apparently, and it may be a depth thing. I don't know. I don't want to blame that too quick. But it's tricky to trace these types through. I know. I guess my claim is A is character. So parser of character is parser of A. We give it a function that takes the result of this, which is a bracket A, array of character. We take input is array of character. The output is whatever monad bind gives us, right? So let's say this should, I'm going to put our real type. So this should be really array of character. Now monad bind 2 of parser 2. Parser 2 is also a parser producing arrays of character. So it should be getting an array of character here. I'm at least documenting what I think I'm doing. Okay, now this value looks to me like an array of character. It's a sequence of two arrays of character. But compact map, well, let's pull it all the way down. Okay, so $0, according to compact map, is an element. It's a function from an element to an optional element. In our case, element, I think element should be a character. I mean, character optional, I guess. And the compact map then should be array of element without a question mark. So he should be array of char. I'm working my way back up the stack this time. Okay, so let me put that over here. That's going up. This is the bottom. These two are going down, 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 down. Okay, so I'm passing in an array of character. At this point, I have a double array of character. I apply compact map to it. It takes every inner character and produces array of character. Then the result type, let's see where our result is. He's a parser of some sort, right? You give me an A, he's a parser of, is he a parser of array of character? So compact map is an array of character. He takes an array and he produces, I guess, a parser of array, parser producing array of character. Okay, which I think is good. Put brackets in here. So the result of results should be a parser returning array of character. Does that make sense from our monad bind? We got input is array of character, output is parser of array of character. Is that what monad bind does? Input is a parser to yielding array of characters. It gets a function that takes a character. Oh. A parser yielding array of characters takes an array of characters and produces some B parser. What is B here? We would really like it to be an array of characters. It produces, this function result produces a parser of array of characters. Yes. Okay. And so when you pass it into the monad bind, you get a parser of array of characters coming out. I mean, I'm convincing myself, but I don't know if I'm convincing the compiler here. Okay. Now function B takes an array of characters, produces array of characters. That's the function for function 1, which goes into a monad bind. So if you pass in a parser yielding array of characters and a function yielding arrays of characters, you should get back a function that goes from array of characters to something. Well, in our case, it's parser of array of characters. You should get back parser of array of characters. Parser? Oh. Okay, now who's messing it up? Is it the compact map? I mean, can I say function 1 is of type array of A goes to array of A? Is that legal? Cannot convert value of parser of array to result type A. Cannot convert value of type array goes to array to expected argument type array goes to parser. Oh, this should be a parser. Parser. That's no, yeah. Function going to the monad should produce a parser of some type. Cannot convert value of type parser of yielding array of double A's to array of A's. So maybe it's this inner thing is not doing it. Result is a parser. So I can't do anything to his stuff. Why is he not getting an array of characters? Well, let's try an experiment here. Let me Let's copy this and muck with it a bit. Result 0, result 0. Get rid of the compact map. And you're happy? So it comes down to, I don't know. This flat map thing. All right, let's make another test. It's only been an hour. Okay, let's make another test that has 2 sequences in it. Okay, so it's going to be a sequence of match A then B with match temp of C. Okay, and if you get ABC, I would love to see flat ABC here. I don't know that I will. Test succeeds with nested sequences. Okay. I think it's going to pass, but I don't know. No, it's not. ABC is not equal to AC, so I've lost something because of the 0. It's like my compact map is not compactifying, or the compiler is not realizing that that the compact map really does produce an array of characters from a double array of characters. And I don't know if I can. Well, let's try this. Okay, let's try my compact. And it's going to take a type A. It's going to look a lot like this. And it's going to take, well, the function goes from element to element. So it's a function from A to A. Well, I don't even need that. I don't think I need any function. Let's give it a... I think our type is an array of A's. Well, it's an array of A's, and it's going to produce an array of A's. Okay, so let's just return n sub 0 for a moment. Should fail the same way. Whoops. Input. Oh, I'm not calling it. Sorry. So it really will fail the same way. My compact of all of this. Okay, and that ends result. That ends the parser function. Okay. Cannot convert type A to expected type array of A. Oh, we need the result. Okay, I think this should fail the same way. Now I got two failures. AB is not equal to A. ABC is not equal to A. Okay, so I think it's dropping stuff. It's only returning n sub 0, so yeah, it's got the loss of it. Okay, but what I want to say, and I don't know if I can, I want to say return input dot compact map of $0. Cannot convert value of type array of A to closure result type A. A optional. What the heck? Oh, man. Well, this is the heart of it, isn't it? I don't know if I can... does this justify this? Return result. Let's start off. Let's do it manually. Yeah. Result of type array of A. Okay. And then for each... let's see. Okay, my input is $0. Each one of these is an array of A's. So if I run over every input, and then this is array n. second to it. For each result.append $0. Okay, so I got a doubly nested array. I've got a doubly nested loop. I get down to each individual element that's an A, and I append it into my result. It seems okay from the typing point of view. Let's see how it does. I don't know why I can't get compact map to do this, but maybe, well, okay, wasted a bit of time with compact map. I think the issue may be that it can't quite, I don't know if it can't quite trace the fact that this type returns itself. I think it's regarding it because it wants an AB, it just regards it as a B, and it's maybe just not recognizing that. I don't know. But I don't think it's a, well, what do I think? I shouldn't have to do this. I do think that. I may be able to find another function that will do the thing for me. That would be nice. Okay, and let's inline function 1. You don't inline. Okay, let's grab function 1. Okay, nothing. Return doesn't need it when it's the only thing. Okay. Oof. Wowzers. Okay, so the good news is, I think the great news is, I think this proves that my operation is flattening things as we go, and that at least will solve some of this char problem. I'm not sure it fixes everything, and I'm not sure what happens. We still have to have these onlys, I think, but I'm going to try one more thing. All right, so the other thing in my head is that sequence like this, I really would like it to just be an operator. And up here somewhere we did or. I tried this. I don't think anybody's using this. Let's make sure everything's okay. Yeah, so you can see this reflects my original sequence thing. Well, okay, this one is a 2 and this one's a 3, but the problem with the 2 is I've got the 2 coming in. They produce a parser of array of A's. It returns result rest, which is the pair we want, but the type of result is now array of A's. And if I passed another thing into my array of A's, it would be falling apart. Okay, but I want to do this. I want to say function ampersand of A, okay, should take whatever my sequence takes. Let's pull this down there. Well, let's pull sequence up here. We'll straighten things out in a second here. Okay, pull this one. So his type is going to be exactly the same as this. Okay, and I think his result is going to be a sequence of parser 1, parser 2. Okay. And all right, let's try this. Right, and now in my test, yeah, let it pass first, Bill. All right, in my test, I'm going to get rid of these, and I'm going to say this. Okay. Oh no, come on. Oops. Extra print. Okay. Match temp A and B and C. This is what I want to say, and I want to get that result. I really want to say it and really want to get it. Okay. That's progress. Now, well, let's do this one. Get rid of this. Now, I don't know. You may hate the user-defined operators, but I think in the end, I think we can get our grammar looking really like a BNF, and that will be pretty valuable. So we have to be explicit about the ampersand coming in, but I think this is progress. Okay, take a quick look over here. Yeah. Okay, and I think we can make this function private now. File private. Oh, who's calling him? Oh, yes, this is the same version of sequence. Now the only problem I see so far is that this sort of says every parser has to be ready to return arrays of stuff. And that's not really true just yet. So I think the conversion to use this is going to be a little more complicated. Sorry, that should be ampersand, right? Oh, that's all new. Oh, okay. Sorry, let's see. I believe I should have been putting ampersand here. It is seek parser. Okay, so seek fails if first parser fails, and fails if second parser fails, and succeeds if they both succeed, and you can do nested sequences. And flattens result. Maybe succeeds with flattened result for nested sequences. Okay, because that's really what I'd like to see. Yeah. All right, I think this will go. All right, so I'm going to check in because we're at a green bar for an hour plus. We've been getting there. Provide monad bind result and seek parser combinators. Right, we are. Okay. Now, this, let's get down here. Match temp, I think the callers are exactly those tests we just looked at. Yep. And match temp, we didn't change anything other than the name. Okay. All right, so I don't know how painful it was to watch. It was painful enough to live, but I feel like this is a major improvement for me in potentially anyway. That now I can use this ampersand operator, and I can pick off things. Let's see if I can pick stuff off. So we'll get rid of match temp. Okay. This is being called indirectly, so I'll make up file private and move it up to where it's being used. So we're just doing some plain old refactoring now. It's a relief after all that mess. Okay. Okay. And then I think these two, they're kind of fundamental and they belong up top. Well, not at the very top, but maybe after match and accept. Okay. Run that. Okay, so we refactored, delete dead code, reorganize file. Okay, and then let's just tackle something. Okay, so end-of-line comment is a sequence of dashes and a skip to, and it's combined. So I would like to think, let's make a new one. I'm not that confident, apparently. All right, so instead of sequence of these things, I would like to just say match and skip, and I guess I'll keep that first thing. So you match, skip, and you combine the whole thing into ast.ignored. All right, let's run tests. Nice. Okay. And I'm going to switch EOL comment to use new parser sequence operator. Okay. All right. So I have this thing. I think this is more readable. Okay. So it's just doing a match of these and skipping to new line. Not nested. Here's some minis. Here's some unlines, unwraps. I'm hoping we can get rid of a lot of these sequences and turn them into the regular ampersand operator. So it's time for another break. We'll take a couple minutes. I'm going to grab a drink, come back, tackle these, converting these to use the new sequence form. And if they work, I think our nestable comments will go back to that problem and see. But we've definitely made a dent in a good. I mean, it's a real problem here. I've got two sequence parsers. One takes an array of parsers and produces a parser of arrays, returning arrays. This takes a parser of A, returns a parser of array of A, and returns a parser of array of A. Or it takes a list of them, not in braces. It's just, it's mucky. It's messy. Okay, that's dead. And if as I hope, I'll move this down slightly. Put that in here. My hope is that we can switch everything to use this ampersand, and these two functions just go away. And they were messy, and keeping track of which one was which was a problem and all that. So I'm feeling good. All right. Relief off the shoulders. I can feel relaxing. All right. See you in a couple minutes. Okay. So I did some refactoring there, right? So reorganized. Dropped some dead code. Yep. Okay. And I don't know, I should mention that physical thing of tensing up and all that. It's something I kind of developed. I think it just came out of my natural reactions, but I kind of have intentionally used them over the years. So when I have a failing test, I kind of mentally and often physically hold my breath a little bit, waiting for it to pass screen. Okay. And same thing with refactoring. When I get stuff, well, ideally your refactorings are just little touch, touch, touch. Each one's good and go. But sometimes you have ones that more like take the car apart and put stuff on the table or on the floor. Um, those make me nervous, and I definitely tense up the more stuff I'm juggling in the air with that. And I feel like I consciously use it, and then now my unconscious kind of takes advantage of that and tries to tell me like, "Hey, you're tense. Why are you tense? Because something's wrong." And it'd be nice if you found a smaller step way to do things. But I've definitely felt that with this monad change. I mean, the type system is trying to help, and that's a good thing. The only place I think we have a character parser is that very first one, match. Yeah, so match with a predicate. We can see we'll see what happens there. I don't know, but we may turn it into a array or something at some point just to make things work out, or provide another one, or I don't know what. But I do leverage that, and it's not accidental really. All right, so my hope here is, let's save nestable comment. Let's tackle integers. Okay, integer literal is fine. No sequences. This one is a sequence, so it's a sequence. Let's get the matching brace. Okay, so every comma, top level comma. So this one is certainly an and. This one is an and. The optional goes to here. There's nothing after it. Okay, and now I can take the sequence off. Let's see, the blast brace before the bar. Okay. Does this work? I may need parentheses. We'll see. I should have left the parentheses and then taken them off. See? Little bit of tension there. Okay. Nice. All right. And then here's another sequence. Let's find its thing. Okay. Now this is inside, so this does need parentheses. And this optional closes here, and character one needs many. Okay, so this is saying match either E and optional sign and many digits. That seems like a good thing. And then I can take this off. That should still work. I've still got extra parentheses. So the reason I picked bar and ampersand, they have the precedence I want already relative to each other. And I'm not doing any other. Well, we might have a ampersand that drops something or something like that. Unable to type check. Try breaking it down. Oh. Okay. Let's see if this lets it type check. Okay. Oh, still building. I was thinking about breaking it down anyway because this matches that. Okay, let's break out the exponent. Is going to be this. And this is also match E or E and match plus or minus and match many digits. Okay, so this is also float exponent. You can see why I worried that the levels might be the issue with that compact map. I think that may be what was going on. Okay, let's formatting. Okay, optional float exponent. Okay. Many. Okay, have I lost something here? The combine. Something's not right. Okay, I think I just need to... Yeah, I think this... Okay, you can either be... Yeah, it's really this. Okay, so I hate to reorganize if it's going to mess it up. No, not really. Okay. Well, these really are at the same level, so I don't know why it spaced them, but okay. So a float literal is many digits followed by either a dot, digits, float exponent, or just the float exponent. The reason this is you can say 3E7 and you get a float. But yeah, so let's put things on the line together that link together. Okay, or float exponent. Right, so that's a sequence of those two things that... Okay, make sure I didn't mess up anything. Right, okay, I'm gonna take advantage of small commits here. So refactor to use ampersand sequence operator. Split out float exponent. All right, so now this can come out, but this is an ampersand. Okay. And so it's either, maybe I can take a little spacing to make it match up. I don't know. I think this is Elm style, right? Okay, so we're saying it's a bunch of digits followed by either a float exponent or dot digits float exponent. But we can't just put optional float exponent on the end, because if you just have digits by themselves, you're an integer, and we're trying to distinguish the two. Okay, and here we have expressions of float literals or int literals, and it tries float literal first because it's the longer match, I guess. That's the way to say it. You have to worry a little bit with the OR bar with that, with this parser combinator approach. Not that it can't work, but you're making less work if you match the bigger things first. Okay, so let's see. Switch to use ampersand separate sequence operator. Okay. That's much nicer. I like it. Now I can see it would be nice to have something that was like match. See, I've got two matches. I don't know if that's right or not to do, but this one, when you give it a string, it looks for exactly that sequence of characters. I would like to have something that's like the brackets in a regular expression, where you put bracket ABC and that is match A or B or C, the literal character. It we're gonna have to see on that. The other one I see in this is look at mini one. See, it's kind of given a parser, it repeats it one or more times, but optional is a prefix function. I would like to get rid of that. And maybe that's a good goal for today, is clean up this grammar a little further. Okay, but yeah, we haven't tackled nested comments yet. And the reason it's on hold is because it wasn't working. And it wasn't working because we were getting so many nested thises and that's, I couldn't keep straight what was going on. So let's try again. Okay, so this parenthesis, anybody at the top level turns into an ampersand. Okay, and this isn't going to be in Martin's book. All right, that should work as is. I think a sequence can take one thing and handle it correctly. It doesn't mean anything. It's just do it, but let's make sure that is true. Okay, and I delete the word sequence because I've got this whole expression. Now that should also pass. Okay. Now, this is where I'm not clear if it would be nice. So, okay, so you see this part here is where the unwrap starts. It's that stuff. It would be nice if I could just put these in parentheses. All right, so I'm hoping I don't need unwrap anymore. We'll see. That's no. Failed. Cannot convert parser of character to parser character. Oh. Parser of character. Okay, let's undo this. Let's do the inner one first. So sequence of ampersand match dash with things that are not dashes. So here I've used except. Boy. Let's see, my mind was like, why don't we make except with an A, take a set of characters, and except take a set of characters. But except takes a set of characters. And if you're in those characters, it does not accept it. Okay, so that's the same as not this or that. All right, I hope this passes. It compiles. I don't know. I don't think we have our tests activated enough to be sure if things are working right, but they never were, so I think it's okay. All right, let's do this. All right, now where's the parentheses for the inner dot many? I believe I should not need an unwrap at this point. Okay, if that compiles, oh, close. Is it going to complain or not? Failed. Oh. Unwrap. This is okay, right? Yeah. Okay, so let's lock in this. All right. So we switched more grammar comments to use and sequences. Okay. I don't know who's creating the trouble here. Maybe I'm going to go do the optional thing because I think that's an easier win. So this sequence, I think the deal is this much is producing an array of characters, and I think, no, is it producing an array of characters? We're going to have to look at our many. Do we have other uses of many? Okay. I think they're all many ones, and maybe my many's type is insufficient. Okay, yes they are. All right. Let me do optional. I don't know. It's just I don't want to face it. Let's find many. Optional. It's a parser producing an array of stuff. Optional produces an array of stuff. Many one produces an array of stuff. So is optional? Where's optional? Yeah, so if you call a if you call a many one, you get a parser producing array of stuff. And if you put that in a optional, yeah, this is return empty input. Parser of array of A's produces parser of array of A's. That's true and good. But are we getting a parser of array of A's here? So the sequence produces, let's see, this much. Wait a minute. Where's this match to? Oh, it matches that one. Except dash many. Okay. So what does except do? We haven't looked at him today. Match, except was just above my abide. Okay, so match produces array of except produces array of single character. Who uses except? I don't think it's anybody else. Colors, parser tests. See, I think he needs to do this. And maybe I need a match that produces an array. Maybe that's the place I'm going off here. Okay, let's take, we're going to rename that function match, at least to match 2. Okay, so he's a separate thing. I'm saying I really wish match 2 returned an array of characters so I could use him with my other monady parsers thingies. Okay, and if I return character in the array, and he returns parser of characters. Now, this file should be fine. The test should be a little iffy, and the Elm parser may be off. Okay. Oh boy. Okay, cannot convert value of parser of character to parser of character. This is boy. Oh, where's my many? Many is a parser returning array of characters, but I really would like him to be arrays in, arrays out. And this is where I'm worried I may have to bend my whole parser type. Let's see. Oh, boy. The other paper had brackets around the A input and no optional. And they weren't using a language that supported optional, so I don't know. Element, character, and character require to be equal. Yes, I think that's the true issue. Okay, so we can extract pieces. Okay, so the type of this is parser of array of characters. I don't think I can do this. Let's give it a shot, but I think lots of things will break. Yes. Not a lot of things. Oh, there you go. Okay. Yeah. Ambiguous. See, that's the killer one. Okay. Undo. Where's my thing that peels it apart? Optional unwrap. Let's put an unwrap. Let's move the unwrap inside. Is that gonna work? String. Okay, this is this new type for accept is an array of stuff. Except rejects doesn't matter because it returns nil. Okay, so we just made accept return an array, and we made all its uses aware of that, is what happened. Okay, so let's find accept. Okay, and it returns match to, which well, I think I can say match dot only. Yep, and get rid of this. Okay. So I don't know if you remember only, but it wraps something that's in a singleton to an array of them. Okay. So accept now. Okay, can I go further? I would like to get rid of this unwrap. Nope, this unwrap. I don't think it's going to let me. Where are you going? Okay, so we can leave the parens and just do the unwrap. Yeah. Okay. We still haven't busted him out totally. Okay. I'm going to save that for next time. It doesn't feel like a 5-minute job. This optional thing though, I think we could do that one. Let's look at optional. Okay. Now the difference is, see, this is a bare function because it's used on the outside. It wraps things. This one only is an extension because it's modifying. It calls self.parse to get its value. But I think we could do the same thing. Okay, so if I do extension of parser and a var optional of parser of brackets of A, I guess. And I do all this. I may just need to say A. Parser, yeah. I think that might be okay. And he calls self.parse. And that. Type of expression is ambiguous. Okay. I'm going to call it opt for now just to avoid the name clash. Cannot return an array input because it's a parser producing A's. I don't want to put only on here. Cannot return parser producing A. Yeah. Cannot return expression of type array. Result. Okay. Result is a pair. I know it's not empty. I think I can do this. Result.0, result.1. Okay. And now bracket result.0. Say parser returning array of A. Is that going to do it? Just to make sure. Clean and build. No. Cannot return expression of type parser of A. Well, is this parser of bracket A? Okay. So much for easy, right? Cannot return A input. Optional A input. This. Okay. Let's try. Let AST result. Let's let A result equal. Oh. A rest equals result bang. Okay. And if I return bracket A with rest, I think that's okay. Okay. Do you build? Yes. Nobody calls it. Let's change it out of our optionals. Where's that? Yeah, this one. Now I don't know if I can put it on here. This dot opt. Okay. All right, let's revert. I think this was unfortunately not as easy as it looked. Parser. Yep. In our test. Top. Oh shoot, I merged two things. Expected, except. So parser, we'll get rid of this. We'll undo this. Okay. Let's see where we are. Okay, so we're making okay. Well, it's array of character. All right. Well, I think this is looking good, not perfect, but we've definitely made a dent, because otherwise we had 1, 2, 3, 4 things stacked up, and you had array of characters versus array of characters. And we've flattened that out some. I think we just have to work, just the magic word, just have to work out the consequences and make sure that everybody basically takes characters, arrays of characters, and returns them. And then these monad kind of rules apply, because you can take all the elements, flatten them, and return that result. Now, I don't know, at some level you may not want to flatten things, and I'm not sure what we'll do there. But like, notice this combine converts it to an AST, which is our interpreter type basically. And you can have, we'd like our parser to be so generic that it doesn't care if it's working with characters or ASTs or whatevers. So we got a ways to go, but I'm very happy we got this far. I think it's a big dent in things, and I feel like I'm starting to get my handle on how that monad bind works, and that'll serve me well for a good while, I think. All right, well, thanks for joining me. I hope you can join me in the future. Next time is Tuesday, what is that, the 26th? Tuesday the 26th, 1 to 3 p.m. Eastern Time, and take care till then. Bye-bye.